A ball of mass m is attached to a string of length r and negligible mass. The ball moves clockwise in a vertical circle as shown above. When the ball is at point P, the string is horizontal. Point Q is at the bottom of the circle and point Z is at the top of the circle. Air resistance is negligible. Express all algebraic answers in terms of the given quantities and fundamental constants. On the figure below, draw and label all the forces exerted on the ball when it is at points P and Q respectively. Next bit. Derive an expression for V minimum, the minimum speed the ball can have at point Z without leaving the circular path. Next bit. The maximum tension the string can have without breaking is Tmax. Derive an expression for vmax, the maximum speed the ball can have at point Q without breaking the string. Next bit. Suppose that the string breaks at the instant the ball is at point P. Describe the motion of the ball immediately after the string breaks. This question is in uniform circular motion, and this is an FRQ from the college board. In this question, we have to derive two quantities. They are minimum speed and maximum speed. When the ball is at Z, that means at the topmost point, what is the minimum speed? We have to derive an expression for the minimum speed. And when the ball is at Q, that means at the lowest position, lowest point, what is the maximum speed? So obviously, when we are saying that the question is in uniform circular motion, so the forces are always directed towards the center. And here, the tension force is directed towards the center. Am I right? Here, when we consider the point Z, the forces acting are the tension towards the center, and then gravity is also acting downwards, so that is also towards the center. So, for the ball to negotiate the circle, the centripetal force is required. Here, the tension and the gravity are providing the required centripetal force. Therefore, the sum of these two forces is equal to the centripetal force. But here, he is asking us to derive the expression for the minimum speed. The condition for minimum speed is tension should be 0. That means the ball can negotiate the curve with the help of gravity itself. The tension is not required. Suppose if the string goes slack, even then the ball can negotiate the circle with the help of the gravity. Therefore, we will write the force equation and then we will derive the expression for minimum speed. Before going into that, the first bit we will answer. He is asking us to draw the forces at point P and point Q. At point P, the tension is towards the center, horizontal. Okay, so I represented this. Gravity is acting downwards. That is also represented here. And at point Q, the tension is towards the center and upwards. And gravity is downwards, that represented here. And then tension and gravity are balancing each other. Now, going back, for B, point B, or the V bit, we will write the force equation. Sigma Fy is equal to F tension plus Fg is equal to Fc. And the condition for the minimum speed is tension must be equal to 0. Okay, so here the tension becomes 0, therefore Fg is equal to Fc. So Fg and Fc are balancing each other. Our gravity is contributing the gravity is the centripetal force contributing for the circular motion. So yeah, we know Fg is equal to mg and Fc, centripetal force, is equal to mv square over r. So here, V minimum we will put because he is asking us to find out the minimum speed, and then we are writing the condition also for that. So substituting that here, we get the solution as V minimum is equal to square root of rg. This is the expression for minimum speed. Next, he is asking us to derive an expression for the maximum speed when the ball is at Q. So at Q, the forces are tension upwards and then gravity downwards. So the net force is towards the center. Okay, so Ft minus Fg is equal to Fc. So the difference in these two forces are the net force contributes to the centripetal force. So therefore, Ft minus Fg is the mg and Fc is mv square over r. Here V maximum. Okay, maximum speed. Therefore, we are writing the expression for the V maximum. So Vmax is equal to square root of simplification. Just I'm simplifying this equation. Ft minus mg is equal to mv square over r. On simplification, I get Vmax is equal to square root of r by m Ft minus mg. Okay. Last bit. Now, according to last bit, if the string breaks when the ball is at point P, what is the path of the ball or the motion of the ball? What is happening here when the ball is at point P? It is going upwards. Okay, exactly at P. Suppose if no other force is acting, then its straight goes up because the given force is that already it has some force. No, with that force, it straight goes up. To what height it goes? Till the velocity becomes zero. Okay, when the V becomes zero, then the object takes the turn and falls down under the free fall. So here it has some force. Am I right? At point P, it has some force. And then the string breaks. Then the object directly shoots up. What height it will go? Velocity, till the velocity becomes zero. Once the velocity becomes zero, then it comes down under the free fall, straight comes down and falls on the ground. That is the motion of the ball at if the string breaks at point P. This is the answer for this question. Hope this helps. Thank you. Bye bye.